Hello, I'm Majda Khalid, the co-founder of Bionics. So we are developing 3D printed bionic prosthetics for people with limb differences, upper limb and lower limb, and it's fully produced in Tunisia. Our prosthetics now are serving 100 patients across North Africa and Middle East, and we are also scaling into Europe. How the prosthetics work? It's actually 3D printed socket. So this socket is adjustable. So you can see with the BOA system, it's lightweight, it's less than 500 grams. And there are sensors in here that can detect the signals from the muscle and drive it into a mechanical movement through our algorithm and AI. Then the AI will mimic the user's daily activity and enhance itself. So basically, this is like a demonstration of how it can be used in daily life. But also the legs part that we have bionic knees, bionic joints and hips that are also connected. And what you can see in here from the socket into the silicone glove is fully customizable. So this can be at any color, at your favorite superhero, even for children. So basically, even the silicone glove can be fully customized from color, gender, and even texture.
What makes you different from all the others in the market?
So, as I mentioned that we are the only and first fully produced in Africa and Middle East. So communities that are 80% of these people with limb differences don't have access to affordable prosthetics. And also it's solar powered. So in Africa and Middle East, there is no access to electricity. So we are trying to access these communities which have the most number of people with amputation, unfortunately.
Can you go into the solar powered part? What do you mean by that?
Basically, our batteries can be solar charged. By charging it through the sun, just it can be charged and fully functional.
How does it charge? Through the skin?
This battery, it captures the sunlight and then it charges itself. So it's like solar panel, mini solar panel.
Tell me about the production. You said that it's 3D printed.
Basically, our model is very scalable, and how we do it is just by having a tablet and a scanner. We just scan the amputation level with the patients. We just get the design and 3D print it with 3D printers. So we will remove all the heavy work that people in creating the prosthetics have been done with the molds and all of the models and all of that. So it's basically, we just need a setup of 3D printers, and you can have the sockets that are personalized case by case. And another thing that we also saw that the rehab part is very, very difficult and long for the patients. So what we offered for them is also an ecosystem for that part. So how we do it is a MyoLink. This is a device that is also connected with a bracelet to the imputed limb, and it detects the signals from the muscle. So through an app which is connected to that, the doctor can see real-time data of that movement, and they can see the signals from the muscle, EMG sensors and all of that, while the patient is playing a game. It's a space game that is like going away from shooting stars, and it's also training their muscle. So we made the rehab much easier, funner and remote. We want everyone to be so conscious about other people's accessibility and how they can have these prosthetics. So we want to collaborate with more people around the world to create and serve for more patients, for the next 100 patients having affordable prosthetics.
Hello, good morning. That's a product of Neuroelectrics called Starstim. Starstim is for monitoring the electrical activity of the brain. So basically capturing the electricity that's transmitting information within the brain and bringing it in form of digital signals. And it has also the functionality to stimulate electrically the brain for the treatment of different diseases like epilepsy, depression, or Alzheimer's disease. So here we are present. This is the device. This could be wireless. It's connected wirelessly to the computer, and then you can collect either the brain signals into the computer and process them to do diagnostics, or you can send commands from the computer into the device for the treatment of these diseases that I was commenting. On the back part, we have a use case for the usage of the monitoring device for emergency units. Basically here, is that you can use the device for measuring the electrical activity of the brain in case of an emergency and diagnosing the conscious state of the person that it's in the bed.
What is the bigger vision? Where are you going with this?
The bigger vision is that you can do with the same device reading and writing into the brain. So basically you are monitoring and then you use this information to stimulate the brain, and then you can do this continuously in a closed loop in order to more efficiently treat this kind of neurological diseases.
How does the monitor work and how does the analysis work?
So you have some electrodes here. Basically, they are placed on the scalp. This is non-invasive. It has a contact with the scalp, and the electricity runs from the inner of the scalp into these electrodes, and then you measure these signals that you can process as you would process any audio signal.
Do you use any special technologies for that?
We use different methodologies, but the most easiest ones are those based on the analysis of the spectral content of the signals. So you may think of an equalizer. When you have in an audio signal, you have different frequency bands. So in the brain, it happens something similar. So you have different frequency bands that corresponds to different functions.
And why are you the leaders?
We have several electrodes. So this is one of the features that is most important about the project, which manages to focalize the stimulation in one particular area. The company has distributors all over the world, so we are already commercializing this. We have 7 million revenues last year, and basically we are trying to certify the devices in the States through an FDA approval.
Hi, so my name is Carlos. I'm co-founder and CTO of AiMA Barcelona and next CEO of AiMA Seoul in South Korea. AiMA stands for Artificial Intelligence Meta-Human Assistant. And as you can see, she's here, she's a beautiful face. The project was born in Barcelona because we have an issue with a lot of elderly people at home with unwanted loneliness. So we set up to create the interface between humans and technology, and we based our research onto cognitive science. We're not doing this based on LLMs because rather it's a trend of LLMs. The focus is on the human brain, how the human brain connects, interacts, and how it connects with other human brains. And from there we created AiMA. It's still a research and development. And AiMA can actually see, as you can see on a webcam here, although she's looking up now. And she can also see in real time with computer vision your 7 basic emotional emissions that you do. Like for example, I'm very happy or I'm very sad. And she can also emit emotions taking into account these kind of inputs. She also now is capable of having complete vision. So she can see the whole environment. She can see that there's a camera actually filming her, and she can describe every single detail of the scene, which is she incorporates that into the whole conversation with the context that it has. Apart from that, she can actually maintain fluid conversation in 13 languages right now, among them Korean, Japanese, and Chinese. And we are expanding and we're adding more capabilities to her.
Is the product itself a software or is it hardware based as well?
Yeah, that's a very good question. So the product itself is software. Everything that you see is in-house developed. All of this is not a video, it's a 3D animation in real time done with the state-of-the-art Unreal Engine, which is used for AAA games. And everything that is running and is actually feeding AiMA is also our own development. Of course, we created it in a modular way, so we can actually incorporate different pieces and then work on these pieces and improve it. And again, as I said, it's always based on cognitive science, and the goal is the human brain, not the technology per se. Technology for us is a tool.
So is that a real human behind the screen being mapped, or how is it happening?
AiMA is based on MetaHuman. MetaHuman is one development of Unreal Engine. We took a face that is not very European nor Asian, nor we did a blend, so it is likable by a lot of people. And from there we just tweaked a few parts of her. Now, all the animation that you see is based on mocap, on real-time mocap that is done to give her that sense of movement. We're also developing the next stage of the animation, which will be completely in real time because it's based on our own development LLM parametric engine, which is able, taking into account the context, to actually move all the different muscles that are in this digital face and be able to express emotion in real time. So for example, if you tell her a joke, she will crack herself up. You will see her laughing like crazy, like a human being would do. In the end, as I said, and I repeat, our end goal is to be as human as possible. And for that, we're basing all our research and development on cognitive science.
Let's go and showcase how it works.
Hey, so I need to use the headphones because it's super noisy here. If it wasn't here, then you don't need these headphones. Hey, hi, so how are you doing today? Do you know that you're at Mobile World Congress? The way she speaks is very human. Again, we're not using ChatGPT or anything like that online. We're using our own development, which is based on how a human being would react and would actually answer. And she's a little bit, she has her own character. Although right now, as she doesn't know me, she's very guarded. She's a little bit, very correct. Now, as the conversation progresses and I give her a little bit more freedom, she will learn from me how I behave and what are my limits. And then she will open up and be even more and more human and more, she will ask more questions, more daring questions. Now, if you ask her a question that she doesn't know, she will go through her agents and search for that question and bring back the answer to you and reply to you. So again, we are very lean in the sense that we're very practical. We're not trying to fight the biggest LLMs in the world because that would be not intelligent. We are focused on the human brain and how the human brain works.
What kind of agents is it using?
When I say agent, it's our own development that is a piece of code that, depending on the instruction that it receives from the LLM, it then executes something and executes a search on the web, for example. Like if you ask her, like, what is the current, my match, the Football Club Barcelona, what is the current, is my team winning? Or she will go search the web and come back with the answer and say, no, actually, sadly, your team is losing right now. I think you made a bad choice. Who is this product for? This product is for every single human being on planet Earth. We want to transform AiMA into the verb Google. I want to Google that for you. I want to AiMA that for you. Because we want every single person in the world, without having any prior knowledge of technology, to be able to access and interact with technology. Because in the end, we're building the interface between humans and technology. And technology can be anything.
Hello, my name is Sabrina. I'm from Mezu, South Korea. It's a South Korean company that is building or making smart patches, wearable devices to detect ECG and also respiration, etc. Our pride is that we have all those products, as you can see. So this is HiCardi Plus. We have CE certification. It's for monitoring real-time patients. We have HiCardi Plus H100. It's a device that is related to Holter. We have also HiCardi Sleep, and we have a similar device which is small like this for babies, also to monitor the baby's arrhythmia or ECG. So we use actually some electrodes to do the measurements, to start the measurements. The patient has to put this electrode like this, turn the device on. Right now I am putting it right here on my chest, the left side, like the direction of the shoulder. When you put the smart patch on the patient, you make sure that the Bluetooth is turned on, because the data will be sent directly to my phone here. So this is my data right now, real-time data. You can see here that it is normal, I'm in a good health, and also the heart rate is 60, the respiration rate, and also the skin temperature. You can also see here the rate of respiration, the rate or the diagram for respirations. So if you move from this device, to the phone, it's Bluetooth. We send the data via Bluetooth. We use this phone as a gateway, and from here to the computer, we use internet or Wi-Fi. Again, as you can see here, this is my data. More details, respiration, heart rate, and temperature. S is for skin. The patients can go home if they don't need to stay in the hospital, but they need to be monitored and checked, that they can be sent to home, and the doctor, they can check them on the system on hospitals. We have some alarms. So if there is a yellow alarm, it means maybe the patient has checked or touched the patch. So if it is red, he needs help, and we can send emergency.